We started the linear inequations yesterday for standard 10, and we'll continue the same topic today. We are going to talk about replacement set and solution set today. What is a replacement set and what is a solution set? Now, for example, an equation is given like x is less than 3. For example, x is less than 3. Now, if I do not know what x is, I cannot find a solution set, because I don't know whether x is a natural number, x is a whole number, or x is as an integer, or x is a real number, or what is x. Until unless it is not defined what x is, I cannot find the solution set. So the set for which it is defined, like if I say x belongs to set of natural numbers. If I say x belongs to set of natural numbers, then this set of natural numbers is a replacement set for it. It is a replacement set. And what is set of natural numbers? 1, 2, 3, 4, and so on. This is the replacement set. The values for this inequation will come from here. The values for this inequation will come from here. And what is the value? Less than 3. Less than 3. That will become the solution set. Replacement set is, this is your replacement set. This is replacement set. And I want to find out that what is the solution. Then solution will come from replacement set. Like x is less than 3, so solution set will be 1, 2. Only two elements will be there, 1 and 2, because they belong to set of natural numbers. So I'll have the solution set as 1, 2, while this is the replacement set. Suppose he had said, this is a part, if he had said that replacement set is, I'm writing it by RS, replacement set is x belongs to set of whole numbers. X belongs to set of whole numbers. Then the solution set would have been 0, 1, 2. Because whole numbers will be 0, 1, 2, 3, and so on. So he says, what is the replacement set here? Set of whole numbers. So the solution set will come from the replacement set itself. Solution set for this particular equation would be 0, 1, 2. Now suppose it says replacement set is x belongs to set of integers, where I am not defining integers or positive integers or negative, we are saying just integers. So that means -2, -1, 0, 1, 2, 3, and so on. This is set of integers. Now how will we find the solution set here? Solution set will be any number which are less than 3. So it will be a -2, -1, 0, 1, and 2. This will be the solution set in this case. And if it says replacement set is x belongs to set of real numbers. Suppose x belongs to set of real numbers and x is less than 3. So we'll have to write it in the set builder form. Solution set x such that x belongs to set of real number and x is less than 3. This will be your solution set. Because when we say real set of real numbers, then all the numbers which are less than 3. Suppose I want to represent them on a number line. 0, 1, 2, 3, 4, 5, -1, -2, -3. Now it says all the numbers which are less than 3. 3 is not included in this. 3 is not included in this. Less than 3. So all the numbers which are less than 3, this will be the set of real numbers. This is the solution set for this particular thing. So solution set, replacement set. Replacement set is the solution set will come out. Solution set will be subset of replacement set. Solution set will be subset of replacement set. Now let us see some questions are given in the form of true and false here. They are given in form of true and false here. Like he has given you a question that is state true or false. He says if A is less than B, if A is less than B, that implies A minus C is less than B minus C. That means if we subtract the same number from both sides of the inequation here, the sign of inequation remains the same thing. That means if A was less than B, then A minus C is also less than B minus C. That we discussed yesterday, the property that if in an equation a number is subtracted, the same number is subtracted from both sides of the inequation remains the same. The sign of inequality does not change. So this statement will be true. This statement will be true. Now it says if A is greater than B, if A is greater than B, then it says A plus C should be greater than B plus C. This is again the thing which we had done yesterday, that if A is greater than, this is an inequation, and if we add the same number on both sides of the inequation, the sign of inequality does not change. The sign of inequality does not change, so it is true. It is true here as well. It is true here. Now the third one is if A is less than B, implies AC will be greater than BC. Now what has happened is that he says A is less than B, and if I multiply it with some number C, then the sign of inequality reverses itself. Now it depends, we told you, if C is a positive number, then it is false. If C is a positive number, then it is a false, and if C is negative number, then it is true. So in general we don't know what is the nature of C, so we will say this statement is false. Otherwise he should define what C is. Though in the below he is saying C is greater, no, for F it is saying, so we don't know what the value of C is there, whether C is positive or whether C is negative. So if I am not aware what is the value of C, whether it is a positive number, whether it is a negative number, but for your information, if it is a positive number, then this statement is false, and if it is a negative number, then this statement is true. But because he is not given the nature of the C, I will consider it to be false. Now let us see the fourth one. He says if A is greater than B, that implies A upon C is less than B upon C. Again, this is division. I do not know the nature of C. I must know the nature of C to define. Nature of C means whether C is a positive number, whether C is a negative number. I have no idea because he is not given in the question that what is the nature of C. So that is why this statement is also false. But in division and multiplication, if the numbers are positive, then the sign of inequality does not change. But if the numbers are negative, then the sign of inequality reverses itself. But because I don't know what is the nature of C and he has not defined the nature of C, I will say this statement is false. Now let us see this one. if A minus C is greater than B minus D, that implies A plus D will be greater than B plus C. This is true. This is true. It is simple transformation from one side to another side, so it is true. I have brought B to this side and C I have taken to that side, so it doesn't matter. And it is, now it says the sixth one. If A is less than B, if A is less than B, and here he is defining C, and C is greater than 0, that means C is positive. Yes, only C is defined. Out of the sixth question, he has not defined in the 5 question what is the nature of the C, but for the sixth question, he defines the nature of C. C is greater than 0. Then it says A minus C is greater than B minus C. It will be false. Sign of inequality cannot reverse itself when we are subtracting. When we are subtracting and C is greater than 0. C is greater than 0. So you cannot reverse the sign of inequality for this case. That is why we cannot do this. We have few questions on inequations to solve where the replacement set are given and you have to find the solution set. For example, the first is 3 minus 2x is greater than x minus 12 and x belongs to set of whole numbers. We go exactly in the same fashion as we solve an equation. That is, we are going to bring x terms to one side and constant term to one side. Like if shift x to this side, it is minus 2x minus x greater than 3 will go to this side, minus 3 minus 12. It is minus 3x is greater than or equal to minus 15. Now, the only difference between equation and in an equation is, like if it was minus minus and it was equal sign only, we would have just removed minus sign from both the side. But here, by removing negative or by changing the sign, you will have to change the sign of inequality. If you are going to divide it by, suppose what I am going to say, I am going to divide both sides by minus 3. So minus 3x will be divided by minus 3, so it will become plus, and minus 15 will be divided by minus 3, so it becomes also plus. Or if it was plus, it becomes minus. By dividing by a negative number, the sign of inequality reverses itself. Like it was greater than, it will become less than. So x will become less than 5, less than equal to 5. X will become less than equal to 5. So the solution set would be, it is set of natural numbers 1, 2, 3, 4, 5. And if he asks you to represent it on the number line, the number line is 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2 and so on. The number line should be always shown as going to infinity, to plus infinity, also to negative infinity by indicating an arrow here. It is 1, 2, 3, 4, 5. It's a discrete set. It's a discrete set. So 5, 4, 3, 2, 1. These are the elements of this set. These are the elements of this inequation. They should be circle and shaded. That means only these are the elements, no other element is there on the set. So this is the solution set, and that is how we represent it on the number line. That is how we represent it on the number line. But this is the step which should be noticed. Here, when I am dividing both sides by a negative number, then the sign of inequality will reverse. In equation it doesn't happen. In an equation it happens. Now let us see question number 2. In question number 2 I have 8 minus 3x is less than or equal to 20 x belongs to set of real numbers. X belongs to set of real numbers. So here it will become minus 3x will be less than 20 minus 8, or minus 3x will become less than 20 minus 8 is how much? 12. Now again I want to make x to be positive, so I'm going to divide both sides by negative 3. And when I'm going to divide both sides by negative 3, then the sign of inequality will reverse. If I divide it minus 3x by minus 3 and 12 with minus 3, the sign of inequality will reverse itself. Here it was like this, here it has become like this. It is to be noticed. It was less than equal to here, here it became greater than equal to. So x is greater than equal to minus 4. X is greater than equal to minus 4. How do I write solution set? First of all, I say x belongs to set of real number, and x will be greater than equal to minus 4. This will be written in the set builder notation only. We can't write it any other way. If I have to represent it on a number line, then of course 0, 1, 2, 3, it is greater than equal to minus 4, minus 1, minus 2, minus 3, minus 4, minus 5, and so on. Now greater than equal to minus 4 means it will be going to this side, and it is equal to minus 4 also. It is equal to minus 4, that is why I will draw a line straight up and indicate an arrow this side. And all these values, because it is only for set of real numbers. It is only for set of real number. All the numbers which are equal to minus 4 or which are greater than minus 4, all the numbers are the members of this set. So this is the way to represent it a number line. Now let's see third question. In the third question I have 5 plus x upon 4 is greater than x upon 5 plus 9, and x belongs to set of real numbers again. X belongs to set of real numbers. So what am I going to do? I'm going to bring x term on one side, constant term on one side. That is x upon 4 minus x upon 5 on this side, greater than 9 minus 5. So we will do the same thing as we do LCM 20. So 5x minus 4x greater than 9 minus 5, 4. Now I am going to multiply, and this will come x upon 20 greater than 4. I will multiply both sides by 20. Both sides by 20. So we are multiplying with plus 20, so it doesn't make any difference. Sign of inequality does not change because we are multiplying with plus number. So x will be greater than 80. X will be greater than 80. If I have to write it, I will write it. X belongs to R and x is greater than 80. If I have to represent it on number line, then I will go to starting 0, suppose 80 somewhere here, 81, 82, 83, and so on. So I will say greater than 80. It is greater than 80. 80 is not part of it. It is greater than 80. It is not equal to 80. In the previous question it was equal to also. Here it is greater than 80. So that is why this concave kind of a thing is drawn into that side. So it is greater than 80. Now let us see question number 4. X plus 3 upon 8 is less than x minus 3 upon 5. X belongs to set of real numbers. So I can multiply both sides by 40. 40 plus, so it is not going to change anything. Why by 40? Because LCM is 48 and 5 are there in the numerator. So x minus 3 into 5 into 40. So 8 5s are 40, 5 8s are 40. So 5x plus 15 is less than 8x minus 24. Bring x term to one side and constant term to one side. That is 5x minus 8x will be less than minus 15 minus 24. It is minus 3x is less than 39. Now both sides will be divided with negative 3. Minus 3x divided by minus 3 minus 39 divided by minus 3. Whenever you divide with a negative number, the sign of inequality will reverse itself. It was less than, it will become greater than. Notice here. It was less than in the previous. When I divided it with minus 3, the sign of inequality reverses itself. X will become greater than 13. X will become greater than 13. So solution set will be x belongs to R and x is greater than 13. And if I want to write it on number line, then 0, somewhere here, 13, 14, 15, 16, then greater than. Greater than 13. Greater than 13. So he is not asking you to do it on the represent it on number line. I have done it because finally we are going to do it. We have to do it. Now, fifth question. Two into x minus 1 is less than equal to 9 minus x. X belongs to set of whole numbers. Replacement set is set of whole numbers. So 2x minus 2 will be less than equal to 9 minus x. Bring x term one side. 2x plus x is less than equal to 9 plus 2. 3x is less than 11, or x will be less than 11 upon 3. 11 upon 3 means if you divide 11 by 3, 3 3s are 9 and 2 will be 3 6 are 18. 3 3s are 9, 2 will be left. So 3 3s are 9, 3 3s are 9 plus 2 11 upon 3. So it is a set of whole number. It is set of whole numbers. So what will be the solution set? Solution set will be 0, 1, 2 and 3. Because this is not whole number. So only 3 is the whole number. So till there. And if you want to represent it on number line, 0, 1, 2, 3, 4, minus 1, minus 2. So 0, 1, 2, 3. You make circles around them, shade them. It's a discrete set. When you are talking of real numbers, you are talking of continuous sets. So you get the value here. You get the value here.